Hi everybody. Had a few people asking me about question 9, so I'm just going to whiz through it. So we've done a bit of this before we went into lockdown, but with cos, sine, and tan. Here we're doing it, continuing that, but with the cosec, sec, and cot coming into it a bit. So if sec a equals -3, and a is between pi over 2 and pi, we need to read into this and think, well, that must mean that a is an obtuse angle. So then we look at sec being 1 over cos a. So sec a equals -3, 1 over cos a equals -3. Therefore, cos a equals -1/3. Then we can, bearing in mind that cos a is the adjacent over hypotenuse side, I can draw out this triangle and find the opposite side to be 2√2. Now those will allow you to write down the correct ratios of sine and tan, and then we've got to think, are they going to be negative or positive? And it was this stuff, just bear with me, it was this stuff about the graph. So if we know that, if we know that, so for sine, for example, if we know that a is between pi over 2 and pi, all of sine a is going to be positive. But for tan, oh my god, apologies. Tan, for tan pi over 2 pi, tan a, oh for God's sake, tan a is all negative, it's down here, and so we can use the triangle to get the correct ratio of 2√2 over 1, but then because I'm told that a is obtuse, I stuck in a negative there and a negative there, so the exact value of tan a is -2√2. Then for b, it's to do with cosec a. So in order to write this out, I need to know sine a, and again, sine a is going to be the opposite over hypotenuse, so we've got 2√2 over 3. And as I've just shown you, because a is obtuse, sine a will be positive, and so we keep it as 2√2 over 3, and then it's just using surds, what we know about surds and cosec, to show that it equals 3√2 over 4. So if sine a is 2√2 over 3, cosec a is 1 over that. You flip the denominator and the numerator, and so you get 3 over 2√2, but that's not what we need it to be, so it's tied it in with a surds question, really. You need to show that if we rationalise the denominator, it simplifies to what we need it to. Okay, cheers.